All right, if you're getting into C programming, there's one thing you just can't avoid: arrays. Seriously, they're everywhere. They are one of the most fundamental tools you'll have for organizing data, so getting a solid grip on them is, well, non-negotiable. So, in this explainer, we're going to break down exactly what they are and how you can start using them.
So here's what we've got on tap. We're going to start with a classic programming headache, you'll see why in a sec, to really understand why arrays are so darn useful. Then, of course, we'll introduce the array as the hero of our story. We'll start with the basics, one-dimensional arrays, then we'll kick it up a notch with two-dimensional ones, and finally we'll wrap it all up with a key takeaway so you walk away knowing exactly when to use which tool. Okay, let's dive right in. Section 1, the 50-variable problem. Yeah, it sounds a little dramatic, but trust me, before you can really appreciate a good solution, you've got to feel the pain of the problem first. Let's look at the chaos.
All right, so picture this. I give you a task. How would you store the test scores for 50 students? Just 50. Now, if you didn't know about arrays, what's the first thing that comes to mind? Probably the brute force method, right? Just create a separate variable for every single student.
And yeah, you'd end up with something that looks like this: an absolute wall of variables. It's a total mess. And it's not just that it's a pain to type out. It's a complete nightmare to actually work with. I mean, imagine trying to find the class average. You'd have to literally add up 50 different variables one by one. It's clumsy, it's super easy to make a mistake, and it just doesn't scale at all. What if you have 500 students? No way. We definitely need a better system.
And lucky for us, there is a better way. Which brings us to Section 2, the array solution. Let's see how we can wrangle all that data chaos and bring some order back into our lives.
So, what is an array really? Well, at its heart, it's just a container. And I love this analogy. Think of it like an egg carton, right? It's got a fixed number of spots. Every single spot holds the exact same type of thing, an egg, and they're all lined up, one after another, nice and neat. An array does precisely that, but for data, inside your computer's memory.
Okay, now there are 4 key rules you've got to get down. First, they're homogeneous. That's just a fancy way of saying all the elements have to be the same data type. You can't have an array of integers and then suddenly throw a character in there. Nope. Second, the memory is contiguous. This is a big one. It means all the elements are stored right next to each other, side by side in memory. This is what makes them so fast. Third, the size is fixed. Once you decide how big your array is, that's it. It's not going to change. And finally, and listen up because this is a big one, especially if you're new to programming, indexing is zero-based. The first element is at index 0, the second is at index 1, and so on. Seriously, remember that one. It trips up so many beginners.
So how do you actually make one of these? Well, the syntax in C is pretty simple. You just tell the computer 3 things: what kind of data you're storing, what you want to call your array, and how many slots it needs, inside square brackets. So when you write a line like int numbers 5, you're basically telling the compiler, hey, go find me a block of memory big enough to hold 5 integers, line them up, and from now on, let's just call that whole block numbers.
Okay, enough theory. Let's see this stuff in action. We'll start with Section 3, arrays in one dimension. This is the simplest kind you'll work with. You can pretty much just think of it as a straight-up list. Now, a really common thing to do is to fill up the array with values right when you create it. So here, we're not just declaring an integer array of size 5 called R, we're also saying, and, by the way, fill it with these numbers, 10, 20, 30, 40, and 50, using those curly braces. This is super handy and probably how you'll set up a lot of your arrays.
And this table here, this shows you what's actually happening under the hood, in the computer's memory. You can see each value is stored right next to the one before it. See those memory addresses? 1000, 1004, 1008. They're jumping by 4 every time. Why 4? Well, that's because on a lot of systems, that's how much space or how many bytes a single integer takes up. And over on the left, there's our trusty zero-based index from 0 to 4, pointing to each value in the array.
Okay, so you've got your data in there. How do you get it back out? Easy. You just use the array's name and the index of the element you want, inside those square brackets. So if you want the very first element, you'd ask for ARR0, and you'd get back the number 10. And if you wanted the last one, well, in our 5-item array, that would be ARR4, which would give you 50. See? Simple.
All right, you've got the simple list down. Let's level up. Time to talk about two-dimensional arrays. Now, don't think of these as a simple list anymore. The best way to picture a 2D array is as a table, or maybe a grid, like a spreadsheet.
So a 2D array is really just an array of arrays. That's the secret.
When you see this syntax, int matrix 2, 3, what it's really saying is create an array with 2 slots, and in each of those slots put another array that has 3 integers. When you initialize it, you can see that structure perfectly. The big outer curly braces hold the main array, and then each little set of inner braces is one of the rows. So we get one row with 1, 2, 3, and a second row with 4, 5, 6.
And when you look at it logically, it forms this nice, neat grid. It's not just a line of numbers anymore, it's a full-on table with rows and columns. And just like with 1D arrays, everything is 0 indexed. You have row 0 and row 1, and column 0, 1, and 2. This kind of structure is absolutely perfect for things like a game board, a spreadsheet, or, doing matrix math.
So how do we grab a specific number out of this grid? Well, now you need 2 pieces of information, the row and the column. You need coordinates. So if we wanted to find the number 6, we'd first go down to row index 1. That's the second row. And then we'd go across to column index 2, the third column. That specific spot, matrix 1, 2, is exactly where the value 6 lives.
All right, we have covered a ton of ground here. So let's bring it all home and talk about the most important part, your programming takeaway. In other words, how do you choose the right tool for the job? Okay, so when do you use a 1D versus a 2D array? Honestly, it's pretty straightforward. If you've just got a simple linear list of things, like our original problem with the student test scores, a 1D array is your best friend. The analogy of a single row of lockers is perfect. You just need one number, the index, to get what you need. But if your data naturally fits into a grid or a table, think a game board or an image or a spreadsheet, then a 2D array is the clear winner. It's more like a chest of drawers. You need to know which drawer to pull out and where inside that drawer to look.
So at the end of the day, that's what arrays are all about. They bring structure to your data. They take that chaotic mess of variables we saw at the beginning and turn it into something organized, efficient, and easy to access. They really are a cornerstone of, well, pretty much every programming language out there. So the foundation is laid. The real question is, what are you going to build with it?